So in the previous video, we learned that an inverse function interchanges the domain and the range of the original function. And we also saw how to find an inverse function. However, if we are given two functions, how do we go about verifying or proving that they are inverses? To prove that two functions are inverses, what we need to do is do compositions twice. We're going to compose f with g of x, and we're going to compose g of f of x. So in other words, we're going to go both directions. And if we end up with x in both scenarios, we can conclude that the two functions are inverses. So we're going to prove the following two functions are inverses. So we're going to go both directions with our composition. So first of all, we're going to put g of x into f of x. By everywhere there's parentheses, I'm going to open up, everywhere there's an x, I'm going to open up parentheses, and I'm going to insert g of x. And I'm going to do the math. I'm going to distribute, giving me x plus 5, and then I have the minus 5 from the original, and that produces just x, which is what we should get if they are inverses. But now we need to switch directions and do g of f of x. So that means this time, everywhere there's an x, I'm going to put the blue f of x function. And now I'm going to do the algebra. Distributing produces x minus 5/3, and then I have the plus 5/3 producing x. So I'm going to write my conclusion. I'm stating that f of g of x is equal to g of f of x, which equals x. Therefore, f of x and g of x are inverses. This time I'm given that f of x is equal to 6 over x minus 4, and g of x is equal to 6 over x plus 4. So again, we're going to do the composition both directions. I'm going to use this notation this time, g of f of x. And I'm going to see if I get x both directions. So this means I'm plugging g of x, this one, into this one. So I will have 6 over x, which is 6 over x plus 4, and then I have the minus 4. All right, so now I'm going to clean this up. That's going to produce 6 over the fraction 6 over x, and then dividing by a fraction is the same as multiplying by its reciprocal. So this is equivalent to 6 times x over 6. So my 6's would cancel, and I get just x. Okay, let's do the other direction, plugging f of x into g of x. So I'm going to plug in the 6 over x minus 4 here. Okay, so again, I'm going to use this idea that dividing by a fraction is the same as multiplying by its reciprocal. So this would produce 6 times x minus 4 over 6. That complex fraction comes out nicely. My 6's cancel, leaving me with just x minus 4, and then I have plus 4, so this cancels, resulting in just x. So again, I'm stating that f composed with g of x is equal to g composed with f of x, and they both equal x. Therefore, f and g are inverses. Kendra earns $8 an hour, works at least 40 hours per week, and receives overtime pay at 1.5 times her regular hourly rate for any time over 40 hours. Her total earnings, f of x, for a week in which she worked x hours is given by f of x is equal to 320 plus 12 times the quantity of x minus 40. First of all, explain why the inverse f inverse of x exists. Then find f inverse of x. So f inverse of x exists because it passes the horizontal line test. Now let's find the inverse by switching our x and y. And then we're going to do the algebra and solve for y. So this produces 320 plus 12y minus 480. Combining like terms gives me 12y minus 160 equals x. I'm going to add 160 to both sides to isolate y, and then I'm going to divide by 12 to get x plus 160 over 12 equals f inverse of x. Next we're asked, what do f inverse of x and x represent in the inverse function? Well, it's just testing, do you recognize what your new variables are? And the concept of inverse functions will switch your domain and range. So my y, or f inverse of x, is now equal to the time in hours, and x would be the earnings in dollars. What restrictions, if any, should be placed on the domain of f of x and f inverse of x? So let's look at the domain of our original function first, which is talking about the hours. So this is assuming she's working at least 40 hours a week, because it's an overtime function. So 40 would be the lower bound on my x. Now the upper bound, think about it. Well, how many hours are there in a week? So I would do 7 times 24. Therefore, there are 168 hours in a week. So though it is very, very unlikely that if someone works every single moment of a week, the upper bound would be 168 hours. Now, as far as the range, well, why do I even need to talk about the range when it's just saying domain? Well, your domain and range are going to flip-flop for your inverse function. So to get the lower bound of the range, if I just plug 40 into my original function, I would get just $320. So you're not getting the overtime wage. So 320 would be the lower bound on your earnings, and the upper bound when you're working overtime would be plug in the 168 hours. So if I do f of 168, toss that into my function, and I get $1,856. So therefore, what would the restriction on my domain be for f inverse of x? Well, it's just going to become the range of the original. So it would be 320 and 1856. Finally, we are asked to find the number of hours Kendra worked last week if her earnings were $380. So it's really asking us, what is f inverse of 380? And we saw that f inverse was x plus 160 over 12. So if we plug in 380 into that inverse function, do the algebra here, that produces 45, and that would be hours.